Alright guys, some big lessons so far. So hopefully you've taken some time and gotten familiar with the organelles inside the cell. Remember in the first video where I talked about how form follows function? Let's unpack that a little bit. Let's look at this heart cell. What's its job? To beat continuously for 80 to 90 years. It can't ever stop. It can't ever run out of energy. It has to keep going. So if we were to look inside one of these cells, we would find that there's a bunch of mitochondria. Way more than, say, in a blood cell. Why? Because that muscle needs lots of energy. What about a white blood cell, whose job is to munch on bacteria floating around in the body? These guys will be chock full of lysosomes to help dissolve and eat anything that the white blood cell finds. The number and type of organelles that a cell has will greatly impact the type of work that the cell will do. That's pretty cool, hey? Alright, back to those cell membranes. So a cell membrane is a wall, and it doesn't want certain things to cross it. Certain things like certain carbs, proteins, hormones, and electrolytes. And I say certain because the cell membrane will let some things pass if the conditions are right. Passive transport is when a solute, something dissolved in a fluid, or a liquid, a solvent, travels without any energy or help. So it just does it on its own. There's three types of passive transport: diffusion, osmosis, and filtration. Diffusion is when solutes spread themselves out or move from a higher concentration to a lower concentration. So imagine we took a drop of red food dye and we put it in a glass of water. What would happen? Well, the red food dye would eventually spread itself out through the glass until all of the clear water is eventually saturated with dye. That's diffusion. It doesn't take any energy and it happens completely on its own. Now let's imagine we had the same glass of water, but this time we put a selectively permeable membrane. So that's a membrane that will let some things pass, but not others, kind of like a cell wall. And we put that membrane in the middle of the glass. So let's go ahead and add that food dye to one side. Depending on what that membrane allows through, either the water will cross the membrane to even out the concentration, or the food dye will. If the membrane allows the water to move, that's called osmosis. If it only allows the solute to move, that's called dialysis. So diffusion, osmosis, and dialysis are affected by the concentration of a solution. And that's how much solute is dissolved in the water. When we compare the concentration of two solutions, we're comparing their tonicity. When comparing two fluids, if they have the same concentrations, they would be isotonic. If one was higher, it would be hypertonic, and if one was low, it would be hypotonic. This is a really important concept to understand if you work in healthcare. We have to be careful about what types of fluids we give our patients, for example, through an IV. If it's a hypertonic fluid, it will cause the cells to leak water by pulling water outside the cells through osmosis, and the patient will become dehydrated. If it's hypotonic, the cells will absorb water, and that could possibly cause the cells to swell up and rupture. The last type of passive transport is filtration. This is commonly seen in places like your kidneys, as fluid crosses membranes when the pressure on one side is higher than the pressure on the other. Kind of like coffee flowing through a coffee filter. Alright, so that's the passive transports: diffusion, osmosis, dialysis, and filtration. No energy required, it'll do it on its own. Let's look at the active transports. So without energy, things will move from a higher concentration to a lower one, or in the case of filtration, a higher pressure to a lower one. If we want things to go backwards, we have to add energy. That energy typically comes in the form of ATP, adenosine triphosphate. The easiest example would be the ion pumps found in the cell membranes. These specialized proteins take an ion from one side of the cell membrane and push it to the other side, from a lower concentration to a higher one. The most common ion pumps would be the sodium-potassium pump, which is used in nerve and muscle cells to transmit information back and forth. Outside of the pumps, we also have phagocytosis and pinocytosis. Phagocytosis is a mechanism in which cell absorbs or eats another cell, bacteria, or debris. The most common example is a white blood cell eating a virus. The white blood cell wraps the virus or the debris in its membrane, and then it uses lysosomes to dissolve it. Penocytosis is a similar concept, but instead of eating solids, the cell pulls water from outside the cell and brings it inside, using its cell membrane.